Alright, so Gauss's law, I'm going to read the statement first. Net electric flux through any closed surface surrounding a net charge Q is given by Q over epsilon naught and is independent of the shape of that surface, right? So there are a few elements here which are very core to this statement, to this law, and number one is net electric flux, right? So you need net electric flux to work with Gauss's law. You need a closed surface, can be any closed surface as long as it is closed, which surrounds a net charge Q, okay, and that flux is given by Q over epsilon naught. So mathematically what we're talking about is phi E, where this is the net electric flux, is equal to Q over epsilon naught, okay, where Q, remember, is the net charge. It is not just one charge or the other charge inside that closed surface, it is the total charge. So if you have a, let's say, a distribution of charge where you've got plus Q, minus Q, plus Q, and these charges are just hanging here, you can imagine a Gaussian surface, right? I'm going to take that Gaussian surface to be this sphere and whose radius is r from the center, and if I can figure out the net flux, right, which is phi E, so let's say phi E, let's say we need to find what phi E is, okay. So phi E is equals to Q net, just to emphasize that we are talking about the net charge inside this distribution, and here Q net will be just plus Q, because what you actually have here is plus Q minus Q and then plus Q, so this cancels, and then you have equals to Q over epsilon naught, okay. So this is what Gauss's law is. You need three things: net flux, any closed surface which is surrounding a net charge Q, and that flux is equal to Q over epsilon naught. Now I'm gonna, so we have seen the definition, we have seen a working example of what this means. So we can figure out what the electric flux is if we know the charge distribution, and if we know flux, the charge distribution enclosed by that Gaussian surface. Yeah, and also, I'm sorry about this, but this enclosed surface is also called Gaussian surface. So if you hear that word, just remember it is the enclosed surface in Gauss's law. Okay, so if you imagine a Gaussian surface, if you know the net flux through that surface, then that is equal to the charge, the net charge inside that surface divided by epsilon naught.